All right, what we want to do is take everything we learned yesterday. Okay, so yesterday was just basically identifying what parallel meant, right, for lines, and then also maybe identifying some locations of angles, correct? Okay, alternate interior, alternate exterior corresponding, and same side interior. And what's going to be important is that you understand that those things are vocabulary and they're going to be used all year. Okay, just think about parallel lines. Obviously, that's all Chapter 3 is about, so that's important. But secondly, Chapter 4, we're going to talk about triangles, and at some point, we're going to add a line into a triangle, and we're going to create basically parallel lines, okay, inside that triangle. In Chapter 5, it's about quadrilaterals, and a very important quadrilateral is the parallelogram, so obviously that's going to have parallel lines in it. And that pattern of parallel lines is going to be something that continually pops up throughout the rest of the course. So these angles, alternate interior, alternate exterior, same side interior, and corresponding become very influential in the rest of the geometry. So we need to make sure we understand it and we can deal with these things as soon as possible. But what we do today is we're going to take the two lines L and M that we talked about yesterday. So yesterday maybe we talked about, that screen's all messed up. So we're going to take those two lines and our transversal. So we got L, we've got M, and then our transversal T. Okay? And we are going to force the relationship of parallelism on L and M. Okay? We're going to take those lines because right now they're converging, right? Right now they're going to intersect. But we're going to force them to be parallel. And then once we do that, what information do we gain about particular groups or pairs of angles? Okay? But the things that we talked about today only exist when those two lines start off as being parallel. Okay? And the first property is actually a postulate. It says if you have two lines that are parallel, okay, and a transversal intersects those. So if a transversal intersects two parallel lines, so you start off with that information. You know that's the picture, that's what you have in front of you, however you want to visualize that, but you know that's a true fact. Okay? Then from that, what do you gain? And in this case, we gain the idea that same side interior angles are supplementary. Okay? Now, what I would caution you of, okay, is that there's going to be, we've got basically four groupings of angles. There's going to be four relationships. Okay? This one's maybe a little bit different than the other ones, but the way I remember this one is same side supplementary. What is that kind of phrase when you're in English class? What's that called? Same side supplementary. Peter Piper picked a patch of peppers or whatever, right? What is that? What's that kind of phrase called? Alliteration, right? Okay. So same side supplementary is an alliteration that might help you remember this relationship. Okay. Hopefully you recognize, you remember that angles 3 and 6 were same side interior angles, and 4 and 5 were also same side interior angles. Okay. But what we're gaining here is that the if part, you start. Come on. You start with parallel lines. That has to be a truth. Okay. And then once that intersects a transversal, your transversal intersects those two parallel lines, the information you gain from that is supplementary angles in this same side interior relationship going on. Okay. That is a postulate. Okay. It is not something we can prove, but it's going to be kind of the basis for the other statements that we're going to come up with here in a little bit. Okay. I have seen in other textbooks, basically we're going to have 4 theorems here. And I've seen in other textbooks they use one of the other theorems that we have as the postulate, and then you can prove this. Okay, it doesn't really matter, but one of these statements has to be kind of your starting point. And it has to be a truth that we cannot prove on our own, and we cannot violate. Okay, so we're going to use that information to kind of help us develop the rest of the theorems in this section. But the key thing is that you have to have that information to be true first. You have to have parallel lines, okay? You might hear me say the word cuts instead of intersects, okay? So cuts instead of intersects, and they mean the same thing. What? What's funny? Zach, what's funny? I like to laugh. What's funny? Some of you do have your. I don't want you guys to put your computers away. I want you guys to be taking notes by paper. All right, so this, this visual here hopefully maybe helps us realize why same side interior angles are supplementary. We can't necessarily, like I said, we can't prove it, but we can get some visual here that might allow us to make the argument. Okay. Basically, what this is doing, it's an animation that's going to allow us to take this angle here, okay, and compare it to the black angle. Well, all we're going to do is we're going to take that red angle, that pink angle, and we're going to basically cut it out, slide it, and paste it somewhere else, and see a relationship. So we slide it out, and we paste it right there. And if I paste it right there, what do you know about that red angle and black angle right there? They're what's going on? Okay? They're a linear pair. And linear pairs are supplementary, right? Okay. So if at that stage, right, so it pulls it right there, and it pulls. Right there, they're a linear pair, right? So if I go back and I remove it back to here, okay, where it started, those two things, not a linear pair anymore, right? Because visually they don't form a line, okay, and they're not adjacent. But as their starting point right there, okay, they are still supplementary. Does that make sense, everybody? Okay. The idea is if this angle here is 30 and that one's 150, then that one is 32 because we're just cutting it and pasting it right there. So because those two make a linear pair, okay, they have to add to 180, and then, well, if that's 30 and 30, that one ends up being 150, then when I just look at those two angles, they're still supplementary, correct? All right. Now, that does not happen. That does not happen if the lines are not parallel. If I look at let's see here. Getting the angle on this stuff is a pain in the butt, but hopefully it serves a purpose here in a moment. There we go. Would you agree that those two angles are same side interior angles? Yeah. Okay. But if I ask this thing to take alpha, which is that angle right there, and add to it beta, okay, and it gives me that total over here of 193.69, right? Okay. If the lines are not parallel, then you're not going to get supplementary. Does that make sense? But once I start, let me see if I can move these lines around. Okay, eventually that number is going to get closer and closer to 180, right? So if I can get that, it was pretty close. Okay, 180. Okay. Now look at the slopes of these lines. Okay. Looking at We'll put it in y equals mx plus b form. Okay, so this is my transversal here that I have highlighted. Okay, but look at these two, F and G, those two lines, 0.24, 0.24. What's that telling me algebraically about those two lines? If their slopes are the same, they are parallel. And then, so those are parallel, and we see then that the sum of those two angles, the supplementary angles, the same side interiors, do add up to 180. Does that kind of make sense? But it only exists, we only have supplementary angles when those lines are parallel. When we diverge from being parallel, we now don't total 180. Okay, it only exists when they're parallel. And that's the important part of realizing when we look at this statement, when we look at this postulate, the if part has to be true for you first before you can get the conclusion, before you can get supplementary. And that's going to be important when we see some test questions. I'm going to give you true or false questions that says, if a transversal intersects two lines, then same side interior angles are supplementary. And that's false, okay? Because I didn't give you any requirements on those two lines, right? So they may be supplementary, but at times they may not be supplementary. So there's a counterexample to that. But if I say if a transversal intersects two parallel lines, then same side interior angles are supplementary, then you say yes, that's true all the time. Does that make sense? All right, so I can delete one word out of that phrase. Okay, I delete the word parallel, and it changes everything that we can argue about that picture. This one here, and I zoomed in the last class and haven't changed it, but basically what this says in the directions is the measure of angle 3 is 55 degrees. Okay? If angle 3 is 55 degrees, and I'm telling you here the markings, okay? That marking right there, that arrow and that arrow in the lines tells us that the lines are parallel. Okay? So they don't have to tell me using words in the description or anything like that. If I look at the picture and there are arrows in that picture, that tells me the lines are parallel. Okay? It confuses people sometimes because of the hash marks. The hash marks mean that they're congruent. Segments are congruent, right? Okay? Well, arrows mean the lines and the segments or the rays or whatever they may be are parallel. Okay? But if those are parallel, from what we just talked about, what does measure of angle 8 have to be? 125. Okay, so measure of angle 8 is 125. So they have to be supplementary because they're same side interior angles, right? Now let's go off of some facts that we know from other sections from previous chapters. If angle 3 is 55 degrees, what kind of angle is angle 1 to, or what is the measurement of angle 1?
55.
It's 55. Why is it 55?
Because
they're vertical. We have the theorem that says vertical angles are congruent, right? Okay. What is angle 6? 125 for the same reason, right? 120. The angle 6 is vertical with 8. Okay. What about angle 2? Yeah, 125 because of what? Okay, it's supplementary with 3, right? But is it also supplementary with 1? Yeah. Okay. So we have multiple relationships here to tell us why angle 2 is 125. Okay. And those relationships all have to be true. Okay. I can't have 3 relationships that are true to show me how it's 125 and a 4th relationship that says, oh, it should be 130. Okay. They all have to be true to say and prove why angle 2 is 125. What's angle 4 got to be? 125. Okay. Because it's vertical here with 2, right? But it is also supplementary with a linear pair with 1 or a linear pair with 3. Okay. What about angle 6? What's that got to be? 55, or I guess it's angle 7. 55, and then angle 5 is 55. Okay? So once you know, and this is always going to be true, once you know the lines are parallel, they're cut by transversal, and you know one of the 8 angles, you know all 8. Okay? You go through that process of using supplementary angles and vertical angles. You can fill in the rest of them. Okay? But here's something that maybe we should talk about, and we'll have some theorems of this. But what would you call angle 3 and angle 5 in regards to the location in the picture? What are they? What would we name them? They're alternate interior angles. Looking at the picture, what do you think you know about alternate interior angles based on the measurements that were just provided? They're the same. They're going to be congruent. Okay? So when you have 2 parallel lines cut by a transversal, just like this postulate said if a transversal intersects two parallel lines, then we have the same side interior information, but now we're also going to have a relationship between alternate and interior angles, and that relationship is that they're going to be congruent. Okay. We also have, if I look at, that angle there and that angle there, okay. What do we call those in reference to the three lines? Alternate exterior. What do you think the relationship between alternate exterior angles are? Congruent. Okay. What is that angle there and that angle there in comparison to one another, and where we identify them, how we name them from the lines? Those are corresponding. What do you think the relationship between corresponding angles is going to be?
The same.
They're the same. They're congruent. Okay. So we're getting four relationships. Three of them say congruency about those angles. The fourth one says supplementary. Okay. Same side or supplementary. And hopefully maybe you see where people make mistakes with this. We'll go through 15 problems, and they're talking about corresponding angles, and they talk about alternate interior, and they talk about alternate exterior. And every single time you use the same congruency idea, right? But on that 12th question or 13th question, they throw same side interior set into the problem or to the assignment. And most people, because it's been ingrained in them to use congruency with same side interior angles, they want to do the same thing, and it gets the wrong answer. Does that make sense? Okay. There is one and only one time when same side interior angles are congruent. Anybody know when that one time is? Think about if these two angles here, those two angles right there are going to be congruent. The lines have to be what? There have to be right angles. We're going to say. Okay, perpendicular. So the transversal would have to be perpendicular to these two parallel lines. Okay, because that would have to be a right angle, and that would have to be a right angle, right? Because they still have the supplementary idea supersedes anything else, so they have to first satisfy that, and to be the same, then they both have to be 90. Okay, and that is actually a theorem that we'll talk about later in this chapter. But I want to prove. So we just talked about alternate interior angles being congruent. I want to prove this. Okay, so what I've done is just gone into smartboard stuff, and I've cut and pasted basically the theorem we're going to try to prove. So this is the theorem we're trying to prove. Don't worry about these numbers right now. We'll kind of clean things up and make it look a little bit better. But when you're writing this down, what I want you to write down right now, this is going to be your given information, okay? And it's really just, all you have to do is write down the L parallel to M, okay? The prove then, okay, is this stuff over here. But remember, the way we develop this and generate that given information, that prove information, is we read this statement, and the if part, okay, becomes your given. All right? A transversal intersects two parallel lines, okay? Well, what we have to do in inside proofs is have lines that we can talk about. We've got to name things. So I'm just going to name lines L and M, and I'm going to force the fact that they need to be parallel. That's the if part. They have to be parallel, and that's what we're starting with, right? So you start, and you know that you have two lines, L and M, to be parallel, okay? It then says, then alternate interior angles are congruent. So this here is what my prove statement should say, okay? So I come over here, and I'm proving those two things, okay? But as I'm developing the given and the prove statement, so we can specify and talk directly about particular objects, we have to draw a picture, okay? So I draw my picture, so L and M are parallel. I have some transversal, okay? So it doesn't name it, but we can call that transversal T if we want to. But then I need to start identifying alternate interior angles, so I just put labels on those four angles that are alternate interior, right? We know 5 and 3 should be a group of alternate interior, and 4 and 6 should be a group of alternate interior, okay? So that's how I would take the theorem written in English words, okay, and convey that or convert that into some geometric concepts that we can talk about, okay? But I want you to understand is that what we have highlighted up here in yellow and blue up top says the exact same thing as what we've got highlighted there in the theorem, okay? That's just specific now, okay? When we go through this, if I could prove 4 and 6 to be congruent, if we can prove that, okay, by default, it also proves 3 and 5 congruent. So we don't need to really go through and prove both congruencies here. Once you can show one set of alternate interior angles congruent, then you have done enough work to show both sets congruent. Okay? So here's the proof. First thing, write your given. Okay? So that's pretty straightforward. L parallel to M, and that's our given. Okay? Now when we approach this, okay, and we've talked about the relationships that we see with alternate interior, alternate exterior, corresponding, that kind of stuff. But when we approach these proofs, the first thing we want to think about is all we know is the postulate that we started the lecture off with, and the fact that same-side interior angles were supplementary. That's kind of the foundation, the only piece of information we know to be a fact about parallel lines right now. So what is a pair of same-side interior angles up there?
5 and 4.
5 and 4, okay? So let's say that measure of angle 5 plus measure of angle 4 is equal to 180 degrees, correct? Okay? Now, if you're a person that said 3 and 6 were as well, that's what you thought about, that's fine, put 3 and 6, okay? It is a true fact. We only need one of these, okay? We only need to look at 5 and 4 or 3 and 6, but that is all we need. And that is we can call it the same side interior angles postulate, okay, which tells us that same side interior angles are supplementary. Okay, I like to write it that. A lot of people want like names for these theorems or postulates, which some of them have. This one has same side interior angles postulate. But if I just remember what names are and not so much what that theorem discusses and talks about and declares as a fact, I might be missing something. I might struggle with some of the things in this course. So this is the fact that is presented inside that postulate. Same side interior angles are supplementary. If you just want to write same side supplementary, I don't have a problem with that. I can read that and understand what that means. Okay. Now, as we go through proofs, there might be some arguments that we could make, but don't necessarily need. For instance, we're going to say 3 plus 6 is equal to 180. Okay, but I only need one of those arguments that is equal to 180. So that might be something that you write in because it's true, but ultimately it's not going to be necessary. It's not going to be needed. Okay, but what I want us to think about is in a lot of other proofs that we've done. Okay, if I get a line like line 2, where I've got two things added together to equal 180, don't I usually have another line of two things added together to give me 180? Yeah. So let's look up there. Okay. Now here's the idea, kind of foreshadowing what we usually do with that, is that hopefully that this new line here that we create, where we've got something plus something equals 180, hopefully that one of these two spots incorporates an angle that we've already talked about. So maybe already incorporates angle 5 or angle 4. So let's just look at angle 5. Is there another relationship with angle 5 that we could add it to something else to get 180? What angle could I add 5 to get 180?
3.
Careful.
6.
6. 5 and 6, because we can visually look at that, and they create line M, right? When two adjacent angles create a line, we call them a what? A set of linear pairs. And we had a postulate that said linear pairs are supplementary. Okay? So this is the linear pair postulate. Again, if that's all I remember is that that's a postulate, but don't remember what the postulate actually says, that might be problematic. That is problematic. Okay? So know that the linear pair postulate says linear pairs are supplementary. Okay? Now that we've got those two things, this is all kind of routine for what we've already done. We've already done 3 or 4 proofs like this. Remember me highlighting and showing you that if those two things are the same, what can you say about those two things? They're the same. So let's do that. Let's write that down. Let's go measure of angle 5 plus measure of angle 4 equals measure of angle 5 plus measure of angle 6, right? What is that idea when basically I've rewritten line 2, when instead of where I see 180 in line 2, okay, so this here is line 2, But instead of writing 180 over here, I write what 180 was equal to in line 3, right? What is that when you replace something with what it's equal to? Substitution. I heard somebody say transitive. This would be fine for this particular problem to call it the transitive property as well. Okay? Because if 5 plus 4 equals 180, and 180 equals 5 plus 6, then we can go that 5 plus 4 equals 5 plus 6. Okay? A lot of times when I talk about these things, I hate saying measure of angle 5 plus measure of angle 6. It just takes too long to say. So a lot of times you'll hear me say 5 plus 6 equals 180. I'm referring to angle 5 and angle 6 as measurements. But now, if you remember back to the other proofs that kind of follow this format, you got two things on the left added together equals two things on the right added together. Okay? And if I look at that, is there something that is alike on both sides or equal on both sides? Yeah, 5 is on both sides, right? Okay? So let's say that measure of angle 5 here is equal to measure of angle 5. And the reason I'm doing that is because eventually we're going to use the reflexive property, just like we just did, and it's going to be a lot more purposeful in Chapter 4, but I want us to get used to saying things are equal to themselves. But it is also important maybe to write that it's the reflexive property, because if somebody's reading my work, okay, and they have maybe a lesser understanding of mathematics than I do, okay, or you do, when we look at this, we want to make sure, because that's an arbitrary number and that's an arbitrary number, right? They're just symbols that represent angle measurements, okay? We just want to tell the people that is reading our proof that symbol, measure of angle 5 on the left-hand side, was exactly the same as the symbol of measure of angle 5 on the right-hand side. And really what that tells us is that when we made the comparison of 4 and 5, okay, comparison of that angle there and that angle there, that 5 was the same angle that was used when we made the comparison of 5 and 6. Does that make sense? Okay? So we just want to tell everybody that 5, it's not something new. Okay? It was the same object in both situations. So now if I remove those, what are you left with if you remove 5 from both sides? Yeah, you're left with measure of angle 4 on the left. Measure of angle 4 on the left. Measure of angle 6 on the right. Okay, so what is it when I remove 5 from both sides? What's that process when we just cancel those out? When you remove something from both sides of the equation, you're doing what? Subtraction. All right, so now we haven't proven what we tried to prove yet. We've got measurements equal. We wanted to get angles congruent, right? But once I have their measurements the same, the degrees of those angles are the same, the angles themselves as shapes should land on top of one another. They should be congruent. What allows me to go from equality to congruency? Good definition of congruency. Okay. And now if you look at this, we started with lines being parallel, and that got us all the way down to eventually saying that alternate interior angles, in this case 4 and 6, are congruent. Okay. Now there's a couple other proofs that we could do. I'm going to kind of skip over them. There's 3 other theorems that we need to talk about, or 2 other theorems at least that we need to talk about. But the proofs for those use the same technique, the same procedure. Okay, so when I want to show alternate exterior angles congruent, I do the exact same approach, where I'm setting 2 angles to be supplementary, using same side interior angles to be supplementary and that kind of stuff, and it will eventually gain me information about alternate exterior angles. There's a couple different ways of doing those. The more I know, okay, so now I know same side interior angles are supplementary, and now I know that alternate interior angles are congruent. I could use maybe both those facts to quickly prove alternate exterior angles congruent. So there's a couple different proofs for those theorems that we're going to come across. But I wanted to do that one because if you go back through your notes, we've seen those 7 steps, maybe 6 steps, 2 through 7. We've seen those over and over several times, right? I just want to show you and get you to realize it's not a new proof. We've done it, okay? And a lot of your proofs are going to be of that nature, where once you see them once, hopefully you see something similar again, you can go back and think about how did I get through a couple of those other proofs to get myself through this one. Very procedural. This one says corresponding angles. Okay, this corresponding angles theorem just says corresponding angles are congruent if, you got to start off with, if the two lines you start with are parallel. Okay, so that idea is going to be seen maybe this applet, if I stop it there, this pause button doesn't work very well. Okay, so if I stop it there before it started turning, did this angle right there land exactly inside that angle? Okay, so when they overlap like that, okay, they were congruent, correct? Were those two angles corresponding? All right, and you can visualize moving any set of corresponding angles, just not just those two, but maybe you want to look at that one. Come on. You might want to look at this bottom one here and that bottom one there, okay? They are as well corresponding, correct? Do they look like they could be cut and pasted and put on top of one another? Okay? So corresponding angles are congruent. And this is maybe this is a demonstration of showing you why, another reason why alternate interior angles might be congruent. If I can take that angle, okay, so take this angle here, slide it up there so they're congruent, and now use vertical angles to show that that's congruent, right? Okay, so these two are congruent, and those two are congruent. So we've got two congruencies. We can use the transitive property then to relate the alternate interior angles. Okay, so that's another maybe proof that would allow us to show alternate interior angles congruent. But you can move these things around. You can move these lines around. Okay, but the idea and the concept is that no matter how you orientate your parallel lines in your transversal, you're still going to get, in this case, if I finish maybe there, you're still going to get alternate interior angles to be congruent, right? So it doesn't matter the nature of your parallel lines as long as they're just parallel. Got to skip over some of this stuff, a couple proofs in here. We'll do that. We'll come back and do that one again. All right, so the idea is that alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and then the last one, same side interior angles are supplementary, right? One of those is a postulate, one of those is a theorem. I really don't care which ones you know. Just if you want to visualize them all as being theorems, that's fine. But the same side one is the postulate that our textbook uses. Where this is going to be useful for you is in problems like this. Anybody know what kind of shape that is? How many sides does it have?
4.
It has 4 sides. So what is the word mathematically that we use for 4? Quad. So that's a quadrilateral, right? Lateral means sides. So you have 4 sides. But in a quadrilateral, we have subcategories of quadrilaterals. Okay? And this one has one set of parallel lines. You may know that song? So with a T over here with a T. Trapezoid. Okay, so we've got trapezoid here. Okay, but what I want you guys to realize is that with that trapezoid, maybe you don't see the image that we've been dealing with like that. You might not see that right off the bat. Okay, but my suggestion to you is to look at the parallel lines. I'm just going to highlight my parallel lines. I highlight my parallel lines in the top and the bottom. I'm going to look at that segment right there because that's a transversal. Okay, so parallel lines and transversals, you can use parts of the lines, right? Does that make sense? It could be segments can be parallel, and segments can act as transversals as well. Okay, so I know, looking at this, that that's 2x, and that's x minus 12, correct? Okay, but if I extend things, does that now look exactly like the image that we've been dealing with? And those two angles now are what to one another? What would be the relation? What would we call them? Those are same side interior angles, and same side interior angles are supplementary. So I'm going to take 2x plus x minus 12, add them together, and they should have to 180, right? Okay. I'm going to leave that algebra for you to finish, okay, because I think we should be able to do that. All right. But I'm also going to look at the other side then. Okay, so the other side Okay, is that transversal, right? Well, that angle there is 3y, and that one's y plus 20. Okay? Kind of ignore this stuff now. It's not a big deal anymore. We've already got the equation. But if I extend that parallel line, that transversal, what type of angles are those green ones? They're same side interior again. 3y plus y plus 20 is equal to 180. And now I can solve that equation for y. Does that make sense? Okay. In your homework tonight, the equations that you set up, the pictures that you set up, you should always be able to take a picture, whether it be a triangle, a trapezoid, quadrilateral, parallelogram, whatever. If it's got parallel lines in it, you should be able to somehow either redraw or highlight and get an image that looks like that. Okay? And when you can do that, I think it's easier for people to recognize, oh, those angles up there were same side interior. That make sense? The equations you set up today should be pretty straightforward, multi-step equations, singular variables in the assignment. Next week, we'll do some of these that have x and y's in the same equation. And then what we have to do, if you have one equation that has x's and y's in it, we need another equation with x's and y's in it, right? Okay, so if I were to give you, just kind of see where we're going with this stuff. If I were to give you a picture like that and told you that this is 2x plus 30, and this was y plus 40, what was the relationship that you would say between those two things? Careful. No? Do they alternate? Do they go back and forth between that line? So they're on the same side as that line, right? And they're interior. So they're same side interior. And so we say 2x plus 30 plus y plus 40 equals 180, right? Now what's wrong with that equation is that there's two variables, correct? So there should be somewhere, at some point, maybe something like that. Okay? And let's actually make it a little bit more interesting. Put a y in there. Now what would be the relationship maybe between those two? Supplementary. Okay? What would be maybe a relationship between those two? Alternate interior. So you can create, I'm trying to get out here, you can create an additional equation, and there might be multiple additional equations, but as long as you can create one that you know to be true, now you've got a second equation with two variables, right? And we can go through and solve that using our system of equations approach, using elimination or substitution. I'm not going to go through, I just arbitrarily showed some values there, and the way I chose them might end up making those angles negative, okay, just because I just randomly chose numbers. So I'm not going to solve this one with you, but that's kind of what we'll focus on later next week. That make sense? Okay. So what we've learned, this is the procedure all year. What we've learned last chapter with systems equations, we're going to start building on that again with a new topic. Okay. Eventually we'll exhaust ourselves with system equations. We'll get tired of doing it. So then we'll introduce factoring. Okay. And we'll do a couple different types of geometry with factoring to practice that skill, refine that skill as well. All right. There's an assignment in Math Excel, 3.2. I don't anticipate it taking you an extremely long time to do. The one thing I want you guys to pay attention to is if they're asking you true or false questions, and it might not occur in the homework, but if they're asking you true or false questions about same side, alternate interior, alternate exterior, and corresponding angles, they're doing it in recognition of that word parallel. Okay, so you've got to pay attention to the if part before you can answer questions that's true or false. And I'm going to give you a short quiz at some point next week that forces you to do that and to read those carefully. So let's see here. All right, that should be open. I'm going to adjust the due date on it real quick.